Dividing with exponents. Simplify to a power of 4. So just a reminder, the big number is called our base. So we've got base 4 and base 4. And then the little number that's top right, the 7, that's a power exponent, and that's a power exponent. To introduce this, I'm just going to rewrite 4 to the power of 7 is simply 4 times 4 times 4 times 4 times 4 times 4 and times 4. And I want to make sure I've got 7 of them. 1, 2, 3, 4, 5, 6, 7. Got it. Okay, and it is a fraction, so I'm just going to give myself a fraction bar. And then I'm going to come back, and 4 to the power of 5 is really 4 times 4 times 4 times 4 and times 4. And then to simplify this, every time we have a 4 on the top and matches up with the bottom, we can cross reduce. So cancel, cancel. So we've got a lot of canceling. For every term in the top and the bottom, we'll cancel. And you should realize this from when you were simplifying fractions. So it looks like I'm left with 2 4s in the top. So 4 times 4 would simply be rewritten as 4 squared. Again, this is an introduction method. Just want to go ahead and remind you that we begin showing our work by writing down the original problem. And actually here, let me go ahead and just highlight this. So 4 to the power of 7 was listed right here. And then 4 to the power of 5 was listed here. And it's simplified to 4 squared. Now we're going to write down the original problem. Let me switch over to blue. Be super clear on this. And I'm going to start by writing the original problem, which is 4 to the power of 7. Divide by 4 to the power of 5. And my next step is after that. Well, notice that how could I use 7 and 5 and come up with 2? Well, you'd simply subtract. And that's actually what we do when we're dividing exponents with the same base. Notice we have base 4 and base 4. Those are the same. We simply subtract the powers. So I'm going to rewrite 4 to the power of 7. That's my numerator. And I will subtract the 5 from the bottom. So that's written as 4 to the power of 7, subtract a power of 5. And obviously 7 minus 5 is 2. So that's going to simplify to 4 squared. And again, the way I'm showing it in blue, that's showing the operation between the exponents. That's the appropriate work that I'm expecting. All right, let's try one more. Okay, so we've got 3 to the power of 5. Divide by 3. I'm going to add a power of 1. And then I'm just going to expand this. So I've got 3 to the power of 5, which means we should have 5 3s. Got that. Give ourselves a fraction bar now. And then I should have 1 3 on the bottom. And then just like we did on the prior one, we will go ahead and cross reduce anything that matches up top and bottom. So I'm going to cross out and cross out. And it looks like I've got 3 4s that are left over. So I'm going to put equals 3 to the power of 4. Well, how would you take the number 5 and 1 and how would you end up with 4? And if you said subtract, that's right. When we're dealing with division of exponents, when we have the same base, you would subtract the exponents here. So now that we've kind of given you the introduction, let me use my color coding just to make sure you can see. So 3 to the power of 5 was listed right there. 3 to the power of 1 was listed right there. Now we're going to get to our appropriate work. But a reminder, in Google Classroom, begin by writing down the original problem. And then what they're going to ask you to do is to show the operation between exponents. So I'm going to start with the original problem, 3 to the power of 5. Divide by 3 to the power of 1. And again, my advice would be give it an exponent of 1 if you don't see it. When we're dealing with division, when we have the same base, we subtract the exponents. So I'll begin with my numerator of 3 to the power of 5, subtract a power of 1. And notice that 5 minus 1 is 4. So I'd have base 3 and an exponent of 4, which is the same thing we had over there. And we'll box that. And that's kind of a quick example. Oh, here, I guess I could put that in there. I forgot to put this over here too. All right. Anyways, box your final answers, and that's how you'd show work for dividing with exponents that have a common base.